Hello, this is part 2 of a longer video looking at how to make a MIDI router using Python. In part 1 we looked at some of the functionality we're going to be coding in and also some prerequisite knowledge and software that we'll need to download. So if you haven't checked that out, you might want to do that first. In this video we're going to start coding. If you'd rather just download the code rather than write it all yourself, then head over to my GitHub page. I'll put the link in the description. Otherwise, let's get coding. On my desktop, I set up a folder called Python MIDI router, and in there I've just got a Python file, a basic template that I've written. This will just speed us along as we begin here. So let's open that up in VS Code. When you get into VS Code, the easiest thing to do is go to File, Open Folder, and if you find that folder, Python MIDI router, that will open the whole folder. So any files in that folder will appear here. I'm just going to open up this basic template Python file, and we'll talk through that now. Just to say as well that I've got autosave on here. I recommend you do the same so that any changes are up to date. So within our file here, you can see at the top, we're importing the python-rtmidi library. The first thing you have to do in these files is import any external libraries because Python runs top to bottom. We're then declaring a couple of variables. These are constants that aren't going to change. In Python, you can't declare a variable as a constant like you can in other programming languages, but the convention is to use all capital letters for constants, so we're using that convention here. And then we've got a function. We've defined a function called MyCallback. This will be called whenever we get an input MIDI message. We need to set that callback, and I'll show you how we do that in a moment. But all it does is print out the two different arguments that go in. And then you've got this section here, which opens up a MIDI import. So what we've got here is the RTMidi library. There's a class called MIDI-in, and we're going to instantiate that class with an object, which in this case we're just calling MIDI-in as well. And then there's a method attached with that class called getPorts. So in this line here, we're seeing what all the different ports are available to us, the MIDI-in ports. Then we're going to loop through those ports until we find the one which matches the name of the import that we've specified above. And then we're going to open that port and just print to the console that we've opened it before breaking out of that loop. And then we're going to run through the same thing, this time with the MIDI out ports. So I'm overwriting this ports variable here, and this time it refers to the MIDI out ports. And you can see this is where I've set the callback for the MIDI in ports. So the my callback name must tally with my callback up there. And then this very last line here is simply to keep the Python script open and running. This just stops and waits for a user to put an input. And if that line wasn't there, the Python script would just run top to bottom, and then it would end. It would terminate because it thinks it's finished doing its job. So this just keeps the Python script open so that we can receive the MIDI in messages. So let's make some changes to this basic template. Let's first of all, we're going to need two MIDI inputs here, aren't we? So I'm going to take this here and just copy it. Okay. Now, because we've got two different MIDI imports, we can't have the object MIDI in for the same of these. So I think it would be better to rename these. Why don't we call this one Arturia in? So I've just changed all three instances of MIDI in there. I'm going to change this one to say Kawai in. Okay. And we've got import name here. If we've got two imports, we probably want to have an import for both. So why don't we call this one input Arturia. That's coming from the little keyboard. I just need to update this as well. Input Arturia. and we'll call this one input Kawai. So there's my two keyboards. In terms of setting callbacks, if we scroll down to the bottom here, MIDI in doesn't exist anymore. So let's call it Arturia in, and we'll copy that as well. Kawai in. There we go. So we've set callbacks for both our MIDI imports there. Now we need to know what the actual names are of these ports. So let's do that now. So if I just go here and print these ports, let's see what we have. So I'll run the Python script just by pressing this play button in the top right here. And you can see that it's printed all the MIDI imports. Now the import for the Arturia then is this one here. So let's just copy and paste that in. The Kawai is coming through the interface, so that's that one there. And then I need the output name. So let's stop that script running and let's now print the output names. So here's the outputs. It is erroring. What's happened here? Oh, I know what's happened. Within the Ableton Live setup that we had, if I go over to the MIDI preferences again, can you see that we've actually already opened this MIDI import within Ableton? So we're going to have to close this down. So let's just do that. And this one too. We're going to be using the LoopBe internal MIDI within Ableton. Okay, so let's just set that now. And if I try and run the script back in VS Code, I'm hoping now. Yep, so there's no issue now. You can see that it's opened the MIDI import for the Arturia. It's also opened the UMC there. And then it's printed out all of the outputs. So the one that we want to use, the one that we've just set up in Ableton there, I think is that one there. So let's copy that. And we need to paste that here. Okay, just stop the script there a minute. Close those down. Right. So at this stage, we've managed to open up both imports and the output. Let's just delete the, don't need to print the ports anymore. It's worth mentioning that when you have multiple MIDI devices connected like this number at the end here can change. Now, the LoopBe, we don't need to worry too much about that happening, but certainly these two, we will. So what I'm going to do actually is take off the number from the end of each of these, and I'm just going to change this line here. Let's just comment this line out a minute. And instead, I'm gonna say this instead. If the name is in the particular port we're searching, then open it. Now it's a subtle change, but what it's basically doing is it's checking, when we loop through all of the ports here, rather than checking for the exact name, what it's going to do is see if that port name includes that information. So it doesn't matter what the number is on the end now, it will open it, because as long as it says Arturia Minilab Mark II within the port name, it's going to open it up. So we'll make a similar change down here. So let's just change it so that'll just stop it breaking if we end up plugging in another MIDI input device. It should still be stable now. So let's just summarize what we've done. So we've changed the name of these imports and outputs here. We haven't done anything with the callback yet. We'll do that in a minute. We're opening up two different MIDI imports now. We're opening up a MIDI output. Have I specified the name of that? Yes. And we're setting the callbacks for those two MIDI inputs here. Now at the moment then, let's just check this is working. I'm not actually sending any MIDI messages to Ableton just yet, but let's just see if it's registering these events. So if I press a key on the keyboard there, you can see that yes, it's registered a note on event and a note off event. If I do the same on the other keyboard, yeah, you've got a note on event and a note off event. Notice that these numbers are different here, 146, 144. It's just because we're on different MIDI channels here, and similarly here. Okay, I should just say, as we're looking at this, what information are we actually sending to the callback here? It's printing out the event and the data. This is an F string, a formatted string, so it allows us to use placeholders. So if you've got Python 3.6 or higher, then you'll be able to do this. And it's just a quick and useful way to include placeholders with your strings. So you can see that this first item here is a list containing 3 items. It's actually status byte, data byte 1, data byte 2. This is the delta time. So in other words, how long it has been until the last MIDI message came in. So if I go down here now and I press a key again, you'll see it's quite a large delta time at 63 seconds since I last pressed a key there. You can see that it's not sending any data at all at the moment. I don't tend to use the data. Incidentally, if you want to check out all the different methods available to you within RTMidi, if you go over to the website here, you can see that we've got all the different classes, all the information about the MIDI-in class here. And if I just scroll down and find the set callback thing, this is where it tells you that it must take 2 arguments. First argument, 2-element tuple. In Python, a tuple is a bit like an array, but a constant array that you can't change. And then the second argument is the data type there. Okay, so if you want to find any more information, that's where to go. So this all looks to be running well. So in the next video, we'll mess around with this callback function here and get it to start sending MIDI messages into Ableton. Okay, so we're going to do some work on the callbacks now. A VS Code shortcut here, if I press Ctrl K and 0, you can see that it's just folded all the unnecessary things that all of these loops, for example, it's all folded them in. It just means I can see a little bit more clearly what we're doing now, because the only area that I'm actually bothered about in this moment are these callbacks here and this callback here. Now, I want to make 2 separate callbacks because I want different callbacks depending on whether it's a message from the Arturia or whether it's a message from the Kawai. So let's change this. I'll call this one Arturia and I'll call this one Kawai. And now if I just go over here, you can see my callback doesn't exist anymore. So I'm going to call it Arturia callback and I'm going to call it Kawai callback. There we go. Now, it could also be useful just to, if you remember, the event comes with a 2-element tuple. We get the MIDI message and we get a delta time. Now, if I just want the MIDI message, let's define a variable. We'll call it MIDI MSG. And we'll take the first item within our event tuple, which is item 0 for the first one. And let's define a variable status byte. Now, if you remember, event 0, our MIDI message, comes with the status byte, the data byte 1, and the data byte 2 within a list. So currently, MIDI message is a list, and I want the first item within that. Let's define another variable. I'll call this data byte 1. And let's call this MIDI message 1. And then I'll have data byte 2. And we'll say this is MIDI message 2. So now let's have a go at changing this so that we get what the MIDI message actually is. So why don't we say this is going to be an Arturia message, and I like to show the status byte in hexadecimal format, because if you remember, it's much easier. If you look at this table here, you can see it's much clearer, isn't it, when you put the status byte in hexadecimal. So let's have a look at that. I'll also have data byte 1 and data byte 2. I'm not bothered at all about showing the data element. Remember, there's nothing in it. So let's just run that. And it was already running. Let's run that now. Okay, so now you can see the MIDI message here. And you can see the status byte, hexadecimal 92, and then you've got normal decimal values for the other two. So that's useful. It helps us to see what the MIDI message is that's coming in. Why don't we make it send the MIDI message as well? Because currently all that's happening is it's logging the MIDI message within our program. It's not actually sending it onto Ableton. So let's do that now. So remember, we've got this MIDI out object, and there is a method for the MIDI out object called send message, and you can find that in the documentation for RTMidi. And what I'd like to do is simply send this MIDI message that comes in. We're just going to send it out again, so unchanged for the minute. And let's just copy all of this for the Kawai as well. Okay, so I'll just stop the program and restart it again so we get these changes. So as I press a key on here, you can now hear within Ableton, this is now working properly. Okay, and similarly the Kawai. Yeah. So these MIDI messages are being sent now through our Python script. They're not going directly into Ableton, it's going via the Python script. So this is all working correctly here. So in the next video, we'll change the callback functions a little more so that we can adapt the functionality of these things. So in the last section, we set up some basic callbacks here. You can see that it now logs the message here. It logs it with hexadecimal format for the status byte, and then it sends it off into Ableton for us. Just one thing that I didn't catch in the last video here, in the Kawai callback, that should say Kawai message, not Arturia message. So let's just now run this code and check that's the case. So when I press key on the Kawai, yeah. I'm going to press key on the Arturia, yeah. That's still working fine. Now, before we go any further, it'd be a good idea to just make a backup of this. So let me copy and paste that in there. I'll rename this. I'll call it backup, and we'll say basic callback setup. Okay, so we can now refer back to that if we need to at any point. Let's just close that down. So back in our original script here, we're now going to start coding in that note on, note off functionality within our Arturia callback. So we'll do that here. Let's say handle note on off, and we'll write our code in this section here. So what we want to do in this part is to say if we press a note anywhere within our key range here, we want it to sustain until we press it again. So first of all, let's just find out what the note on event is and the note values we're after. So the note on is hexadecimal 92, note off is 82. Remember, the 2 tells you that we're on MIDI channel 3 here. I guess I want to be able to catch it. If I later change the MIDI channel, I don't want it to break. So perhaps the easiest way to do this is let's first define a message type. So message type, and let's say status byte floor division 16. So what this will do is effectively divide the status byte value by 16 and then round down, and in effect it's given us this hexadecimal digit 9 or 8. It's just ignoring the the 2 there, so that we can see whether it's a note on or a note off event. So that now means that we can catch a note on or note off event. Let's catch the note off event first. So if message type is equal to 0x8, and it needs to be within the data range, so within the pitch range. So let's say data byte 1 must be greater than or equal to, it was 48, the lowest value, and also it's got to be less than or equal to, what's the biggest value? It is 72. Okay, so if it's within that range, so this is, leave a comment to ourselves, this is note off within pitch range. Now remember, we want to ignore any note off messages. We only want to deal with note on messages within this pitch range. So I'm just going to say return. That will exit the function early. We don't want to do any more. Let's just copy this and change it now for the note on event. So if it's 0x9 within our pitch range, that's note on within the pitch range, then it depends if the note's already running or not, doesn't it? So I need to keep a record of whether the note's already running. So up in this section here, let's define a new variable called held notes within our global variables section. And this can be a list. And what we're going to do here is just keep a record of note values for any notes that are currently logged on. And remember, this is our data byte 1. Which is giving us the note value information. So that now allows us to, we can check to see whether it's already on. So if our data byte 1 is already in our held notes, then we're going to need to code in something about turning it off. We'll do that in a minute. Else, we're going to need to turn it on. So let's deal with the turn off bit first. So if it's already in the held notes, I'm going to need to remove it from the held notes. So the easiest way to do that is using the remove method, and it'll be data byte 1 is the value that I want to be removing. Within our, if we're turning on the note, then we're going to need to add it to that list, aren't we? So held notes dot append, we'll just add it to the end. Data byte 1, there we go. What about sending the MIDI messages? So MIDI out, MIDI out dot send message. Right, remember we're going to need to send a list, and it will be the status byte as the first item, data byte 1 as the second, and data byte 2 as the third. Now, because we're sending a note on when we actually want to send a note off, the easiest way to change that is just to say -16 to the status byte. So that would change it from, if it was 0x92, it would change it to 0x82. Okay, so that will preserve the MIDI channel by doing it that way. And let's just copy this down here, but get rid of the status byte -16. Because if it's not already running, we just want to send it as a note on event. One other thing, let's just return out of the function in both cases. And then I'll just add a note to ourselves here. So if reaches here, send message unaltered. So this should now work. Just one thing I forgot to do, because we're changing the held notes global variable from within our function here, I'm going to have to put this line at the top here. So this will just now allow us to change the global variable held notes inside this function. So let's run it and check it's working. Seems to be going fine. Let's just up this a bit so I can hear it better. Yep. And the call, I shouldn't be doing this. Good, because that's a separate callback. So it's all working fine. But I'd like to make some changes to this just to make the code a little bit more organized. So we'll do that in the next section. So in the last section, we got the handling note on off functionality working correctly. But as our project starts to grow, you can see that this callback here is going to get quite big and unwieldy. And really, we don't want to keep adding functionality down to the bottom here because our callback would just get really big. We want to use our callback really as more of a kind of decision-making function so that it will forward on to the relevant function. So let's put all of this section here into a new function. So let's define this function here. So define, what should we call it? Handle note off. I'll work out what parameters we need to define with that in just a moment. Let's just copy and paste that in. So you can see here that one of the extensions is flagging the fact that these haven't been passed in. They don't know what they are within this function. So I need the status byte, data byte 1, data byte 2. I also need the message type. So we'll need to pass all those in just a moment. But let's first go up here and change this so that it calls our function rather than doing everything we need here. So I'm going to say if the message type is 0x8 or the message type is 0x9, let's put parentheses around those. So if it's one of those and it's within our pitch range, so this is now saying note on or off within pitch range. Maybe that'd be clearer doing it that way. Note on or note off within pitch range. Well, what do I want to do now? Well, I want to just fire up our new function, which we called handle note off. Okay, and then I want to return. So all of this can now disappear. And it makes our Arturia callback function much easier to manage now. But I'm going to need to, remember, pass in all the relevant things here. So I need to pass in the status byte. I need to pass in data byte 1. I need to pass in data byte 2. And I need to pass in the message type as well. Let's just copy all those. And I'll put those within as parameters for our function here. I could have changed the name of these, but because we're not actually going to change the values of these within the function, it's probably clearer just using exactly the same name in this instance. So we'll go ahead with that. Now, because we're always going to be within the pitch range, if we enter into this function, I can get rid of that part now. So now I can just say if it's a note off, just return without doing anything. I can make this a bit simpler now. I could just make it a one-liner, so let's do that. So now we've managed the note off, and now we're managing the note on, and all of this should just work exactly the same as before. So let's test it out and see. That's working perfectly. So we haven't actually changed the functionality at all by doing that, but we have made the code much simpler within our Arturia callback. So now if there's any change we want to make to the handling of the note on or off functionality, we just go within the function that we've called here. So let's close that down. Now there's one other bit of refactoring that I'd like to do before we go any further. At the moment, I've had to hard code in some values like 0x8, 0x9 here. I'm likely to forget what these mean. So let's just copy in a couple of dictionaries. So these dictionaries are handy kind of reference dictionaries for us. I've just copied them into the global variables section here. So you can see that now we know that hexadecimal 8 means note off and so on. So we could just refer to it quickly. But actually there's an even better way that we can deal with this, which I'll show you in a minute. Also, we've got note values here. Now you can see that it ranges all the way from C-1 through to B9. Now C-1, that is a very low note indeed. I mean, how low is that? So the lowest note on my Kawai keyboard I can get to here is 21. So it's well below the range of my keyboard. But nonetheless, I am going to be using it for firing the pads within our little keyboard here. So I will be using them and we'll keep them in for the time being. So in order to make our code a little neater, a bit more organized and a bit clearer to understand, I'm going to use this message types thing first of all. And back in our Arturia callback, where we define the message type as the status byte divided by 16. Well, remember, this is going to return a value a bit like 0x8 or 0x9. Now, what about if we want to return something like note on, note off? Can we do that? Because that would make more sense if we've got a variable called message type. Well, we can do that. So the way that we do this is we refer to our dictionary and we can pass in our 0x8 or 0x9 as a key to our dictionary. So now when we pass in 0x8, it's going to return the value note off. So message type, rather than saying 0x8 or 0x9, it's now going to say something like note off or note on. Okay. Now, what about if our value was, say, 0x7? Now, that's not in the message type and it would throw what's called a key error. But there's a way of handling that gracefully. We could do it like this. So let's just copy that for the moment. And rather than accessing it, the key directly, what we could do instead is say get. If we use the get method. Now the benefit of this method is it allows us to define a default value. So if it's not there, we can just write other. So I guess that is a safer approach. We could have just used a try except block in order to catch this key error with the first one. But this functionality here does the job with one line. Now, as it happens, this is ever so slightly slower, this second approach here. And actually we don't need it. And the reason we don't need it is because the MIDI protocol says the status byte must be one of these values for the first half of the status byte. So that's okay. We don't need to worry about handling that error here. So we'll just leave that as it is. So now that we've changed this message type here, we need to change this value of 0x8 here. Rather than saying 0x8, we now want it to say note off. And we'll change our 0x9 to say note on. We'll have to make the same change within our handle note off function because you'll find there that we've got an 0x8 and an 0x9. So let's just see. I'll use the find and replace functionality within VS Code just to speed us along here. So yes, we want to change that one. We want to keep that one the same. That's fine because that's just defined in our dictionary. The 0x9 should now say note on, and we'll leave that one as it is. There we go. And I've just realised I've made a mistake there. They should have double quotes around them. Close that down. Right, and let's just run it to check that we're still working correctly. Yeah, lovely. So that change we made there, that is called refactoring because we haven't changed the functionality at all. We've just made it a little bit easier to understand, a little bit more organized. Now this code here is getting pretty long. In order to get around that problem, let's just add an outer parentheses around here, and then it allows us to just put a line break in there so that we can see it all. And this comment's not needed anymore, is it? Because our code is pretty clear. Although saying that, we have hard coded in some pitch range values, and it would be good if we could change those as well, wouldn't it? We could apply a similar approach here. So let's do that now. So using our note values here, we can see that the value 48 corresponds to C3. So what I'm going to do here is where it says 48, let's change that to say note values. And I'm going to look for the key called C3. and that will return the value 48 for us. There. It's just a bit more readable for us as a human being, so that we don't need to remember what these note values are. 72 is C5, so we'll just change that there as well. So a lot more readable now. You could argue that we're slowing down the script slightly by the fact that rather than looking at just a value, we've now got to hunt for the value within our dictionary. But Python dictionaries use a hash mapping approach, which is very fast indeed. So really, it's insignificant. We're not going to have to worry about the hit that it will have on performance by doing that. And the benefits of it being much more organized and readable for us means it'll be much easier to debug, and we're less likely to make mistakes in the first place. So we're now in a better place to start coding in some other functionality, and the next section of the video will be about coding in our control sweeps.